So a brief history of service mesh. In the beginning, you have service A wanting to talk to service B. And in the very primitive past, before you even had the TCP stack in the kernel, you would have to build not only your business logic into your services, but also whatever you were going to use to handle flow control, congestion, etc. And so then connection protocols got formalized, TCP and UDP got moved into the operating system, and you could go back to just focusing on your business logic in your service. It got to be very handy to do service discovery and routing when finding the services you wanted to talk to. And originally, out of expediency, people just built these directly into their services. We pulled all that stuff out into libraries, and then someone had the very bright idea of using proxies. So you would basically have your services talk through proxies to do the service discovery and routing, which got even more refined when the notion of using a per-service sidecar to do that proxying was brought in. And at this point, a really useful observation was made, that these services and their attendant sidecars, as they talk to each other, actually form a mesh, a service mesh. So now to the problem we're trying to face today, NFV in a cloud-native world. In Kubernetes, you actually have really good mechanisms for handling services if you're dealing with L4, streams over TCP, datagrams over UDP. And with some of the things emerging in Istio, even L7 is being handled nicely when you're dealing with HTTP2. The state of network services today is very primitive, right? You've got your payload processing logic, and then you build into those network services whatever the L2, L3 connection management interfaces mechanism is, whether those are interfaces or subnets or tunnels. And this is analogous to very early services, where you would have your business logic and you'd have to do all your own connection handling. But at NFV, we have services that have payloads that they consume that are actual L3 payloads, like actual IP packets. Not the IP packet is bringing us our payload. No, the IP packet is the payload. And similarly for L2 payloads like Ethernet and MPLS. And right now, we don't have a good way of dealing with these in Kubernetes. So the suggestion here is to jump forward into the modern era, keeping your payload processing logic in the network service itself, but moving into the proxy sidecar space, both network service discovery and routing, and also the L2, L3 connection management, whether that involves interfaces, subnets, tunnels, etc. This is directly analogous to the sort of stage at which we broke out into proxies, the service discovery and routing, having already broken out the connection protocol handling into the network stack. So examples of network services. You could think of an L3 domain as a network service. It's a network service whose contract basically is, if you connect to me and you give me a packet to deliver to someone in the L3 domain, I will deliver it to them. If someone else in the L3 domain gives me a packet for you, I will deliver it to you. That's the contract of an L3 domain network service. Similarly for an L2 domain, except around Ethernet frames. And it turns out any cloud-native network function can be defined as a network service. And this brings us to a network service mesh.